So we are now going to resume our program, moving on to panel discussion number 3. And this is Vertical Takeoff and Landing Designs, Enabling Technologies, and Certification. We're very excited about this panel we've put together, and here's the intro. So passenger air taxi and cargo missions in low-altitude airspace have sparked demand for electric vertical takeoff and landing jets, or eVTOL for short. The Vertical Flight Society has recorded over 250 different eVTOL design concepts, ranging from lifting crews to multicopter to vector thrust configurations. This panel is going to cover the enabling technologies behind the emergence of eVTOL, including distributed electric propulsion, battery storage technologies, and autonomous flight systems, as well as their consequences for the vehicle certification process. In addition, this discussion will address the critical considerations for eVTOL designers, including safety, reliability, noise levels, and environmental impact. So with this, I would like to welcome our next moderator, Mr. Jim Sherman. Jim is the Director of Strategic Development for the Vertical Flight Society, VFS. Jim joined VFS in May 2019 as its Director of Strategic Development and is responsible for setting and executing the Society's strategy for promoting membership development and growth. Jim in particular is responsible for supporting the development of the electric VTOL revolution and expanding the Society's membership in this fast-growing market segment. Mr. Jim Sherman has over 25 years of business development, project management, and engineering experience with expertise in developing technology for aerospace, automotive, military, and consumer products. Mr. Sherman has a Bachelor of Science in Electrical Engineering from Pennsylvania State University. Won't hold that against you on stage.
We are. You did the OH.
It's not a real rivalry.
And where's the basketball team ranked? We're not a basketball school.
So Jim also has a Master's of Science in Electrical Engineering and an MBA from Binghamton University. So with that, I would like to welcome Mr. Jim Sherman and the VTOL panel.
Thank you, George. So yes, we are. That's what I expected. Absolutely no one knows what that means, right? So thank you for coming out today. How many of you are familiar with the Vertical Flight Society or the American Helicopter Society? That's what I expected. So a few of you are. A few of you are very active within the society, and we appreciate that. It's on. Better? All right. Need to jack up the gain a little bit. So as George mentioned in my bio, I'm a jack of all trades, master of none. So I've worked around the different transportation industries in various different forms over the last 25 years and ended up here at Vertical Flight Society, mostly because it is probably the most exciting thing that's happening within transportation right now. And I'm really interested in making Blade Runner and Star Wars come true, right? Helicopters are great, but you know, I can't fly a helicopter. I've tried. I'd like to try the one that you mentioned, though. So a little bit about the Vertical Flight Society. We just actually had our 77th birthday yesterday. We were formed in 1943 when engineers from Sikorsky first incorporated in Connecticut to form the American Helicopter Society. It since has grown and shrunk and grown again, and now we're on another growth curve as we've developed into putting together this eVTOL revolution. So if you are interested, if you have any interest whatsoever in vertical flight, I encourage you to go to our website. We actually have two of them that are very important. The first one is VTOL.org. That's Vertical Takeoff and Landing for helicopters. And then there's eVTOL.news, which is the electric side. We have cataloged on eVTOL.news, as George pointed out, over 250 vehicles that are in various different configurations. And actually, it's over 260 now. So it's been going up about 50 different vehicles every 6 months. So we're still maintaining that pace. Some of them are defunct, but they're still going along. We'd love to have you as part of the society, and our primary goal is to advance the industry and maintain the level of safety or increase the level of safety that this industry has enjoyed over the years. So if you're interested, there's some material out on a table out there, membership information, as well as some magazines and stickers. I know everybody likes stickers, so there's a bunch of stickers out there. Or you can come find me, and we can talk about it a little bit. So with that, I'm going to get into the panel. I promised George I would do just a short intro on VTOL. So we have a great panel here today, a good mix of industry, academia, research, and ultimate customer with our U.S. government representatives. So
how come you separated the government from the industry?
Because you're a research guy. Oh, wait, you mean this way? Because he did it in alphabetical order. I also have to commend George on getting 4 panelists with the last name that all start with G. I assume the next panel is going to be H. All right, so I'm going to start with the academic and research and then move into industry. So our first person on the panel is actually not the first person next to me, but it's Dr. Brian German. He's the NIA Langley Associate Professor of Aeronautics at Georgia Tech. He's also the director of Georgia Tech's Center for Urban and Regional Air Mobility, CURM. What a great acronym. His research involves electric propulsion, autonomous flight, and emerging aviation markets that these technologies enable. He specializes in the configuration design of electric aircraft, aerodynamics of distributed propulsion, battery and hybrid electric propulsion modeling, and a bunch of other things. He is a former Fulbright student scholar and an NDSEG graduate research fellow. So Brian, take it away.
Well, thank you, Jim. I think this is a wonderful event, and it's a pleasure to be here. I personally come at this as someone who's interested in aircraft design, and I teach aircraft performance and design-related topics at Georgia Tech. And in my opinion, this is one of the most exciting times in aerospace as a whole that we've seen in the last generation, and in vertical flight in particular. So there's a lot of things going on, as I think John Langford mentioned in his talk. He gave us a really nice introduction to the potential for distributed electric propulsion, for example, where I can reimagine the helicopter. Instead of as a single main rotor or 1 or 2 rotors, maybe I can have rotors everywhere. And I can distribute power electrically. And now I couple the propulsion and the control of that flight vehicle together, which leads to amazing potential to do things like reduce noise, reduce operating costs of the vehicle, reduce maintenance costs via the electrification of the powertrain. So we're coming at this new era with a lot of excitement from the technologists. And I think this is a wonderful thing for our students, and it's a wonderful thing for our industry. Along with that excitement, though, comes a lot of challenges, because effectively we don't really know how to deal with these technologies when implemented on aircraft. We don't know how to certificate them. We don't necessarily know how to verify that every flight condition is safe in any failure mode. And so these bring challenges that require research, and they require rolling up your sleeves and doing a lot of good engineering. And so I think that's where we are. Battery technology is another piece of this. As, again, John Langford brought up, if you want your aircraft to fly 30 miles, a pure battery electric solution is amazing because of the operating cost potential, right? But if we then say we want longer ranges, it's not in the realm of the possible anymore. So we're forced into hybrid electric solutions or other. So I would sum it up to say I think it's an exciting time and a potential bright future for us.
Great. Thank you, Brian. Our next one is not next to him. He's over in the corner over there. Ken Goodrich. He's the Deputy Project Manager for Technology for NASA's Advanced Air Mobility Project. He spent most of his 35-year career working in the area of advanced flight system automation and human automation teaming for single-pilot aircraft. His research has been applied to military, civil transport, general aviation, and operations. He currently supports the newly initiated Advanced Air Mobility Project as the Deputy Project Manager for Technology. This project is chartered to lead the development, validation, and flight demonstration of a baseline system supporting requirements of safe, practical, certifiable, and scalable urban air mobility systems. Mr. Goodrich is a graduate of the University
school in Ann
of
Arbor somewhere.
University of Michigan. Yeah, not a rivalry, right? Not anymore. It's Alabama. And George Washington University. So Ken,
Thank you for the introduction, Jim. And I guess this panel is being advertised as focused on vehicle certification and vehicle challenges, technologies. And I'd like to just step back and highlight that we can't look at this from a purely vehicle-centric perspective. You've got to consider all aspects of the system. So there's the vehicles themselves, how they're designed, certified, and manufactured. Then you get into how individual vehicles are operated within the airspace system. That's something we tend to take for granted, but operating in a urban environment, unique flight procedures need to be developed and validated for these aircraft. And again, since safety is paramount, those procedures need to be designed to assure safety even when there's degraded states of the vehicle. So if your performance is reduced with a motor failure, you've always got to have a safe exit from that situation. Next is considering the design of the airspace and air traffic system. So, there's a lot of infrastructure involved there, the CNSI capabilities. I mentioned flight procedures for individual aircraft, but of course on top of that, you've got to consider how you're going to move many aircraft through that system simultaneously. Beyond that static design of the airspace system is how that system operates in real time. You've got to be prepared to handle the inevitable disruptions that'll take place, weather events, closure of a vertiport. Suddenly you may have 20 aircraft inbound to that vertipad that have to go someplace else. We've talked about today how the range and endurance of these aircraft is limited. So being able to safely manage those system-wide disruptions is a key consideration that ripples, of course, all the way back to the design and certification of the vehicle itself. The final, I wouldn't necessarily say the final challenge, but another important challenge is the community integration aspect. Typically airports are set away from population centers. They have large safety buffers around them. Here we want to bring the aviation operations as close to our communities as practical. So there's all sorts of elevated concerns around the area, just using examples of noise and safety. And again, those will ripple back to the design requirements for the basic vehicle. There's been discussion this morning about the role of the operator. Is he on board? Is he off board? That raises a whole issue of how you train and certify those operators. And again, what you assume on that front, of course, ripples back to the vehicle requirements and the vehicle certification. Now, at NASA, this advanced air mobility project that I'm representing, our initial focus is on urban air mobility. Although we're anticipating this broader name with the shift to AAM. But I just want to highlight before I stop speaking that we have a two-pronged approach for urban air mobility. There's a near-term focus in partnering with industry in the FAA to get initial operations off the ground. So vehicles need to be certified, pilots need to be certified, and the operations themselves need to be approved. So those will probably have pilots on board. They'll probably operate under VFR flight rules in good weather conditions. That's probably the very near-term operations. So that's the first thrust. The second thrust is looking at the longer-term scalability of the UAM system. So how can we operate in as close to all weather conditions as practical? And how can we get the quantities of aircraft through the system that would make this a meaningful addition to our transportation system?
Thank you, Ken. Our third speaker represents industry in this case. It is Mr. Hector Garcia. He's the Urban Air Mobility Engineering Director at Honeywell, the UAM Center of Excellence, where he leads a highly motivated and skilled engineering team in integrating and developing safe, innovative, reliable, intuitive, and cost-effective avionics products and technologies. His foremost technical objective is to certify the Honeywell simplified vehicle operations functionality through the integrated suite of avionics enabling safe and cost-effective operations of eVTOL vehicles for key UAM partners. He's a certified Six Sigma Black Belt, fluent in Spanish, and leads the Honeywell Corporate Society of Hispanic Professional Engineers Inclusion, Diversity, and STEM initiatives. Hector.
Thank you, Jim. George, thank you. Great job in putting this together, and I'm honored to be here in the panelists with my esteemed colleagues here. I'm very pleased to represent the industry of technology. I'm here to speak on the enablers for this fascinating times that we're in. This is a once-in-a-lifetime experience for all of us here. There are wonderful technical challenges that we're incorporating. I want to be able to enable through safety. And one of the things that we want to represent, Honeywell has a great tradition in providing safety for our aviation industry. We want to continue, and we want to be, one of the things that we want to work on is to come from the background to the forefront. For those of you involved in aviation, Honeywell is on every single aircraft aviation in the world. This is more than just domestic. Our emphasis is safety. We work tightly. The second enabler that I want to talk about is regulations. We work hand in hand, not only with our domestic certification authorities, we work internationally. And then lastly, to be able to get the public acceptance to realize that technology, and I agree wholeheartedly with some of our previous panelists, that the technology is in front of us today. And I'm coming here, I'm looking to energize the passion in this area to work domestically from the government to state, local, academia, and the technical industries to work for us to get, we heard many times here about first in flight. I don't want to be negative in this area, but we provide technologies globally for all industries. And I can tell you from a technology perspective, we're on pace for domestically to be last in this area. And so I am here to provide the enablers and also the confidence to help and encourage, and the way you brought everybody together, George, is fantastic. And we have to work together to increase and be able to bring this wonderful market into service. So thank you.
All right, thank you. Well said. Our final panelist is from nearby up in Dayton, Daniel Goddard from the Air Force Research Laboratory. He serves as the Senior Manager for VTOL Systems, Aerospace Systems Director at Air Force Research Laboratory. He supports the Director in leading the Air Force's Science and Technology program in propulsion, power, and air vehicles for advanced next-generation VTOL applications. The Aerospace Systems Directorate consists of a workforce of more than 1,800 military, civilian, and contractors executing an annual budget in excess of $700 million and $4 billion in research facilities spread across 65 square miles at Wright-Patterson, Edwards Air Force Base, and Arnold Engineering Development Complex in Tennessee. So, Mr. Goddard?
Thanks, Jim. It's a pleasure to be here today. Thanks very much. Earlier, Jim kind of alluded that I'm an ultimate user of this technology, And while that is hopefully true, the Air Force has taken a different way ahead on this program, and we really want to be more partners. So many of you probably know Dr. Will Roper, he's the Assistant Secretary of Acquisition Technology and Logistics for the Air Force. Very dynamic individual, and about a little over 2 years ago, he said the Air Force is all in on this UAM technology. He first came to the lab and said, hey, look into this, tell us, what's the right thing to do. And the lab did that. They came back to him and said, and we told him, this is really something that's ripe to use just off the shelf. So Dr. Roper has initiated a program called Agility Prime. If you're not familiar with it, please look it up. Just this past Tuesday, 2 days ago, a request for proposals went out on Agility Prime, and it's a very unusual program for the Air Force. It's not a tech development program, which is kind of where the Air Force Research Lab has always been. It's really a challenge program where we want folks, these non-traditional aircraft developers to come, bring what they have, and we're going to give them the opportunity to fly their aircraft in government, military flight space, so it's a lot easier to get done, to help those companies, A, demonstrate their capabilities, and B, help them on towards FAA certification. So the research lab that I represent, we're providing subject matter expertise to help these contractors. We have a couple folks in the audience here helping with airworthiness certification, so Frank Delsing's here, and another individual, Ryan Plumley, who is helping set up some of the tests. So this first opportunity, which only runs through December of this year, is for those companies that are ready to go fly, to write a short proposal. There's just a few constraints. You have to be able to fly 100 miles. You have to go at least 100 miles per hour. You have to carry between 3 and 8 passengers. And we'll work with the Air Force to demonstrate that capability, and we're going to help reduce your technical risk, reduce your regulatory risk, and also reduce the financial risk. Because one of the great things that Dr. Roper, what he's really good at, is going out and drawing up venture capital money. This is, again, a different way for the Air Force to operate, but he's behind us 100%. So I'm here to I'm not so much that AFRL has a lot of tech development going on in this area, although historically we have. We're really here to support this Agility Prime program.
Great. Thank you very much. So those of you that are interested in Agility Prime, if you go to the VFS link on LinkedIn, that was just put up this morning. So all the information you need is right there to go get more information on Agility Prime. There's also information on the NASA Grand Challenge, which I'm sure that Ken, you'd like to probably highlight a little bit about some of the things that are going on in the second Grand Challenge there. Is that fair?
Well, yeah, I guess I'm not sure when you say the second Grand Challenge. So there's 2 events on the calendar right now. There is the developmental testing for the Grand Challenge, and that's NASA partnering with a select set of domestic companies to do sort of dry runs for the event. In comparison to what Dan just described, the focus of the NASA event is looking at the integration of these operations into the airspace. So it has both a vehicle component as well as a second challenge for airspace service suppliers. One of our goals is to extend the UTM airspace management construct into the UAM realm. If you Google on NASA and UAM challenge, you should find a description of the I believe it's 8 scenarios in the event that go from very basic, just complete a mission as planned, to negotiating changes to that plan with the airspace system, to having to respond to a variety of contingencies along the way. So the developmental testing takes place in 2022. The Grand Challenge 1, which is open to all comers, is a 2023 time horizon, I believe.
The great opportunities. I mean, that NASA and the Air Force are doing quite a bit to support the advancement of these technologies, and we should, as an industry and a community, utilize those to the fullest extent possible. And so with that, I'd like to ask first an open question, and I'd like to kind of run down from this end. So we talked a lot about the technologies required for this, and you guys kind of hinted at it in your intros, but what do you see are the enabling technologies, and what are the benefits of those enabling technologies? What do they provide? So Hector, if you want to start that.
Sure. So from a technology perspective, the first enabler that I will concentrate on is we all heard about simplified vehicle operations. This will enable not a highly skilled pilot to be able to operate the vehicle within, and I do not want to concentrate too much on Honeywell's technology, but we have the pedigree to be able to do high integrity, reliable products. We work with the FAA, we work with international agencies to make sure that we have the right due diligence in place. These technologies, in concert with flight controls, with our avionics, are enabled to demonstrate how easy it is to fly one of these vehicles. And most importantly, it's technology that we have been using for decades. In the military side, I have spoken to a lot of my panelists on this before. Our fighter jets are actually designed unstable, and it's our technology that keeps them stable. And maneuvers that could not be done at those high speeds, that confidence has been in the military and in those agent markets for generations. We need to be able to work together with the authorities and regulations and legislation to be able to make the public awareness, to be able to have that confidence. Because at the end, even if we will always concentrate on safety, we will obtain regulations and certifications in this market, but at the end, if the public is not accepting it, it will not come to reality. And it culminates with all of that. And so hopefully, simplified vehicle operations is the way that I would say is one of the key enablers.
Brian?
So I mentioned this topic of what's called distributed electric propulsion earlier. I think I'll highlight that one a bit more. If we think about a traditional helicopter with a single main rotor and a tail rotor, the complexity of that rotor system is enormous, really. That rotor has to provide flight control for the aircraft in addition to providing the lift. And there's a lot of parts that are of a very critical importance for safety, so we can't allow failures. And the helicopter is an incredibly highly engineered aircraft for that reason, and it's an incredibly expensive aircraft to acquire and to operate for that reason. So now the possibilities of electrification come along. What does that mean? It means we can now maintain high power to weight of a propulsion system even as we scale it down. So we could take an electric motor and place it in various places, have many electric motors and distribute them on the airframe. And you see that in the examples presented today. For example, Dr. Langford's aircraft at Aurora and the Elroy Air aircraft. So we have the ability to distribute propulsion, and along with that comes some great advantages. We can now simplify the mechanical systems on the aircraft. So instead of a complex variable pitch rotor system, we could potentially use fixed pitch rotors, and the motor itself is very simple mechanically, having only really a bearing. All the rest of the complexity is held in the electronics and the control systems for the motor. So there's many caveats to this, and we're in the process of learning how to do that effectively and how to do that safely and to achieve this distribution of propulsion while maintaining flight performance at effective levels. And so that's an area that I think that we're going to see more about. And one thing I tell my students is to the point of that was made at Jim's organization, the VFS, is tracking 250 unique eVTOL aircraft in development worldwide right now. That's an enormous number, and if you go look at the pictures of those aircraft on evtol.news, you'll see that they vary vastly in their overall configuration. Vastly. Some look like a multicopter, some have a wing, some do not, some have things that tilt, others do not. And I think what this means is we're at a point in time now where we don't yet know what the dominant configuration will be for a particular urban air mobility mission. We're in the process of discovering that, in part because we're in the process of discovering what the urban air mobility market and mission really is. So in this era of sort of great uncertainty, there's great variability of these configurations that go along with it. I think at some point in the future we'll see that settle out a bit. We will have understood distributed electric propulsion better. We'll understand the market and the mission of these aircraft better. And maybe we'll arrive at 3, 4, maybe fewer dominant configurations and potentially dominant manufacturers down the road.
Yeah, thank you for that reference. We do document everything from the silly to the serious. We don't make any judgment calls publicly. We might talk about some of the designs internally, but we don't make any judgments externally. So go check it out. There are plenty of interesting configurations, shall we say. Dan, do you have something you'd like to add to that?
Sure. So I'll mention maybe 2 technologies that are going to be important for a military application anyway. Well, actually, the first one's going to be important for the commercial side too, and that's sense and avoid or detect and avoid technologies. Sabrina, the representative from the FAA, mentioned earlier that these air vehicles, as they run their flights, are not going to be in a segregated corridor. They need to be integrated into the traffic management system. So they're going to need to be able to avoid aircraft that something is going wrong with. So they need a good sense and avoid or detect and avoid system. AFRL has been developing that technology for a long time. A couple of programs, one's called Auto Ground Collision Avoidance System, another Auto Air Collision Avoidance System. These are very mature technologies. The Auto GCAS system is on every digital F-16. It's on all the new F-35s as they roll off. This system has already saved 9 pilots' lives, pilots that wouldn't have been able to go home and see their family if not for this system taking over the control of their aircraft and keeping them from crashing into the ground because the pilot lost consciousness or became target transfixed or something. So these are fairly mature technologies, but and they need to be adopted by the UAM community. The second technology area that really needs to mature for the military application is probably a hybrid system for the propulsion. The kinds of ranges and payloads that we're probably going to be interested in are higher than what a battery-powered aircraft is probably going to give us. Initially, yeah, we're going to look at the battery-powered. There are some applications for maybe doing hops around a large air base or for maintaining our nuclear missile silos out in Montana, but for some other applications, we're probably going to need a hybrid system. So we want to encourage folks to continue to develop those systems because 10 years from now, that's probably what the Air Force is going to be flying most.
Okay, thank you. I guess my fellow panelists have done a good job describing the immediate technologies that we need to get operations started. So, full-time fly-by-wire augmentation, distributed electric propulsion. As the operations become more complex, more sophisticated, things like DAA, particularly if you want to be able to operate in low visibility conditions, and you go beyond just detecting and avoid, but you actually detect and participate with. Much of the airspace system will probably be based on the aircraft playing a role in the air traffic management. So airborne merging and spacing comes into play. Hector mentioned simplified vehicle operations. A key aspect of that is the automation initially playing a role with helping provide decision support, but then as we want to evolve into unpiloted, uncrewed operations, we need to be going from decision support to decision maker. And of course, a key challenge there is not just being able to support decision making in nominal situations, but it's the off-nominal that's truly challenging. With the panel earlier this morning, a comment was made about in transport aircraft today, well, the crew really doesn't need to do anything unless there's an emergency. Well, that's exactly those emergency, those non-normal situations, particularly ones that can't be resolved just by running the checklist or following the standard operating procedures. Those are going to be the really challenging situations for automation or autonomy to address going forward.
Okay, that is highlighting a good segue into what my next discussion point is. So we've talked about the enabling technologies and kind of have a vision of what that means. Well, you highlighted one of the challenges, so I'd like to ask the panel to elaborate on what you see as the challenges or the obstacles or those things that we need to really go engineer to make this this industry, quote unquote, take off. And I'll leave it to whoever wants to start. Ken, probably since you've had the most experience, why don't you go first and we'll come back the other way.
Okay, I don't know why you say I have the most experience, but
Well,
I think we're all learning here. I would say one of the biggest challenges with this whole area is just the newness of it, the unfamiliarity of these configurations. When the risk tolerance for manned aviation, carrying people on vehicles, it is incredibly low. So the level of uncertainty that we can tolerate is very challenging from a R&D perspective. So I think we've got to figure out how to safely build up actual operational experience with all the technologies as quickly, as efficiently as we can going forward.
without any fabulous failures, right?
Well, there will inevitably be failures, so we have to anticipate those and choose an appropriate mission with the level of risk tolerance to those outcomes that will occur.
So that's a nice setup, Ken, for because that's what Ken is correct. The problem he describes is exactly what the Agility Prime program is trying to address. The good thing about the Agility Prime program is that the testing that we're going to do is in military test ranges, so it's not quite as bad if an unmanned aircraft falls out of the sky. So we can tolerate a little more risk in our flight test program, and it enables the non-traditional air vehicle manufacturer who a lot of things about airworthiness certification are going to be brand new to them. It allows them to maybe take a little more risk, and for the Air Force to bring them along and teach them how to do things according to federal guidelines. So Ken's correct, but I think the Agility Prime program will kind of help that along.
So I'll keep talking about distributed propulsion. That's one of my favorite topics, obviously. I think that one of the challenges of building aircraft that can be certificated with distributed propulsion is that, to Ken's point, really we've not done that much of it before, and so no one really knows how to look at the problem. No one really necessarily knows what are all the corner cases that will stretch and push that design into a bad place that we need to then protect against. Those in the industry may know that we work with so-called fault trees and failure modes and effects analysis, these kinds of things, and good engineering companies are familiar with these and run their designs through the ringer. And that's really important in this case of distributed propulsion, because now it's not just an engine failure means that we're going to be descending, but an engine failure is coupled into flight control. Right, so motor failure in this case is potentially coupled into flight control. So if one rotor fails, okay, maybe I have redundancy and I can handle it, but that's designed in. That has to be taken account of in the design, that the potentiality for any motor to fail could happen. If I have 10 motors, the numbers of combinatorics start to add up. That's different than if the electrical bus fails, right? One of the 2 battery systems fails. Now maybe the entire power available to the aircraft has gone down by 50%. It's a different problem. And when you start enumerating all these potential avenues of failure, it's challenging to manage. It's challenging to represent that in the design space and to then move forward in a test program to verify once you've gone through this process that you've solved those problems. Coupling in issues like thermal management. Thermal management is a big issue on electric propulsion and distributed electric. Turns out electric motors are really efficient. Like, wow, I can get 97% thermal efficiency compared to a gas turbine with about 40. On the other hand, with a gas turbine, we just dump all that waste heat into the exhaust and it's gone. With an electric motor, it's soaking into the structure and it has to be designed a way to get that out of there. So these are new challenges that are maybe not fundamentally entirely new to the aerospace industry, but they're coupled together in new ways. So I think that the test program aspect is going to be critical in designing test plans, and this is both from the manufacturer's standpoint and also the regulator standpoint as well.
It's all you next.
All right, so I'll finish off with the barrier that I see it, and here's the scary part when you have an engineer going to start talking finance, the cost. Our keynote speaker, Dr. Langford, you hit on that. If this is not affordable to the end consumer or to the ones who operate these vehicles, it will not make it into the market. And we will not overlook safety. Safety will continue to be our #1 highest factor that we have to maintain, and we should never compromise on that. But there's a fine line when we start putting regulations and legislation, because there's an infrastructure not only in the air, there's an infrastructure in the cloud, there's an infrastructure in the ground. How are we going to do that? Technology is there already. So we've talked about cybersecurity. It's there. We can protect the data. It's a cat and mouse game. It will always be. But the technology is there. Communications, connectivity is there. It's not built to do this market space. This is where we all have to come in together, not only from the top level, from federal agencies to local agencies to private industry, to be able to make decisions. And the worst thing we can do is to prolong those decisions. If the longer we take, once again, I'll key on, we won't be leading this area, at least in the market space for in-service. But cost is #1. And if you put regulations to certification, you cannot drive the cost down. With technology, we're able to develop architectures today that put the integrity in the right areas and removes them from other areas. And this is where companies like Honeywell that have this rich tradition in being able to do this and being able to provide products and services that are reducing the cost of these vehicles. That's the #1 barrier. Jim, that's the one that I see that needs to be resolved to make this really an enabler. But I'll say it again, it's not technology that is going to be the one holding us back.
Fair enough, fair enough. I guess I'd like to put my 2 cents in from a VFS point of view. I think one of the challenges we have from a certification standpoint is if we're going with a Part 23 type certification, the newly developed standard-based certification hasn't been tried and tested yet. So it'll be a challenge to get through it the first time, but once we get through it the first time from a vehicle standpoint, I think that will make things much easier. But the FAA has taken some steps to make it easier. We just don't know if they really are easier yet because we haven't gone through it. And then from a ground perspective, and you'll hear more about this in the next panel, the infrastructure, the pieces that Rex and that group are going to talk about, will be another big challenge as well. It's not just so much landing spots, but all the things that go around the landing spots, as you highlighted. So
I guess let me add a thought there before you move on, Jim. One barrier that hasn't gotten much attention from the panel is the issue of noise. And one of the things that makes noise interesting is probably meeting the FAA noise requirements isn't a big challenge. So, being quieter than a helicopter, I think everybody's confident they can do that. So you can have a certified vehicle, but the real challenge for urban air mobility is if you want to operate in these communities, they can set their own noise restrictions, and those noise restrictions could be far more challenging what the FAA has established. So, there's both the challenge of meeting those requirements, and there's the uncertainty associated with, we don't know what community expectations are, and it could vary significantly between communities.
And I would like to add a little bit to that. So we do have technology to help with noise mitigation. And eVTOL is just one small step, but there is technology advancements for reducing noise. And, those are the awareness that we need to be able to put out there. Not only do we have that capability at Honeywell, there are others that do that. And that awareness needs to be out there as well. Yes, public acceptance, they don't want some noisy aircraft going overhead. But now with the combination of very smart systems, flight controls, being able to control both pitch and RPMs and maintain stable attitudes can help in neutralizing the noise that occurs naturally. And so, working together with academia, we can actually prove those. We have systems already in place that can actually reduce those decibels greatly. So once again, I'll say technology is in our favor.
yeah, and we actually have in the industry, we have about 6 different committees that are working on that. I think one of the one enabling technology that we didn't talk about, and it's industry-wide, it's not just an eVTOL thing, but it's an all aerospace thing, is the ability that we have these days with the tools to model and simulate and run missions virtually. You can run full-length missions in a matter of minutes and get a noise profile and get a performance profile long before you get a design out the door. And I think that's a huge advantage that we have these days. So with that,
one of the challenges there, Jim, is I just want to highlight that ultimately the acceptable level of noise is a subjective decision made by the community. So the members of that community have to see that this system is providing benefit to their quality of life. Otherwise, any level of noise might be seen as objectionable.
Correct. So with that, we are pretty close, if not over time. So if you would like, I would like to ask you to leave the audience with your last words, whatever you want them to take home with them today from your perspective. And let's go from Hector to Ken. Hector?
So I think my takeaway will be, once again, technology is not a barrier, it's going to be an enabler. And once again, I want to make sure that I want to energize all the way from the top down, from government, like I said before, state, local, academia, and industry, to put us in the forefront of this wonderful market and industry that we're going to be stepping into. I can just tell you that we have a lot of competition internationally, and we need to make sure that we were the first to get in flight. We would love to be, once again, in the forefront for this new era. So that's what I would leave with.
I think I'll just echo Ken's point about the community, and he brought up the issue of noise variability, the variability of noise regulations across the country and how that might influence, or across the world, frankly, might influence the development of this industry and the development of the technology. And I think we can even speak more broadly than noise there. To John Langford's point again of a 30-mile range for eVTOL versus a longer range hybrid solution. What's it going to be? The market will eventually sort that out, but there's going to be a strong coupling between the community related issues, the business drivers and the market issues, and the technology in a coupled way, which is one reason I think events like what George has organized here today is very important, to raise the awareness within communities, to look at things locally, and to think about what futures we want, because I think that's a key bit that will guide the development of regulations and technology as we move forward.
I guess I just want to emphasize how important this technology area is to the Defense Department. Both Air Force, Navy, and the Marines are especially interested in this technology. The competitors that we currently face create some real challenges for your military, and a VTOL aircraft is one of the solutions we're looking at. So this is important to us. It's important to Dr. Roper. He really wants to see the U.S. industrial base be the strongest in this area. That's why he's putting so much emphasis on it. And so I want to thank everyone, especially the industry partners, for your hard work in this area.
Let me just support everything that my fellow panelists have said so far, and just add with the thought that this is probably a journey rather than a sprint, so we can expect this capability to develop over a period of several decades. I liked Dr. Langford's use of the Hartner-Geik hype curve. We need to be aware of that and choose a strategy that allows us to make steady, regular progress up that curve to the mature end state system.
Okay, so with that, I'm going to close with one thing, because you made mention of it. It's not a sprint. So VFS actually has events basically going on every month related to this area. So we talk about different topics, and then if you go on our website, you can see that we've got something going on in March, April, May, June, July, August, September, October, November. We skipped December just because there's just not enough time to do anything there. And then January. So go to our website. You'll find all these wonderful people that will be participating in these events. And hopefully we'll see all of you at one of these events in the near future. So thank you, George, and thank you, audience, for your attention.